Hi everyone, welcome to lesson 12 of pre-algebra. So this is part 3 of our lesson with radicals or square roots. And last lesson we learned how to that aren't perfect squares. And this time we're going to simplify expressions with subtraction and addition with radicals. So starting off, I'm going to explain the concept of this a little bit. So our first example problem is going to be 3 times radical 6 minus 4 times radical 6. Now, this might look a little complicated at first because it involves radicals and the symbol of radicals itself can look a bit confusing. But when you go about problems with subtracting and adding radicals, you always have to think of the radical as like a unit of measurement and not a number. And what I mean by, for example, if you had 3 apples and you're going to subtract that from 4 apples. So apples is our unit of measurement. So you kind of ignore it and you just focus on the numbers. So you do 3 minus 4, which is equal to -1. And then you add the unit of measurement, which is apples. So as you can see here, what I did is I literally just focused and not the actual unit of measurement. So we're going to do the same thing with radicals. So if I move this problem down here, all you have to do is focus on the coefficients of the radicals rather than the actual radicals itself. So when you do 3 times radical 6 minus 4 times radical 6, just as we did with the apples, we just subtract 3 from 4 first and then add on the unit of measurement or the radical afterwards. So if you solve this problem, since we use the same numbers as the apples example, we're going to get -1 radical 6. And when you write the number 1, you usually default it and you kind of just write the positive or negative. So we're going to rewrite that as negative radical 6. And so that's our final answer. So it might be a little confusing at first, but you just always need to remember that you can kind of just ignore the radical and do the math that is presented to you. And don't ever mess with anything that's inside of the radical. Like you'll never do something like this problem. If I use this problem as an example, you will never add radical 6 or subtract radical 6 minus radical 6 and like get rid of the radical. It just doesn't work like that because you have to think of it as a unit. And so this rule only works if the radical that you're working with is the same on both units. So last problem we did 3 radical 6 minus 4 radical 6, and both of the radicals were the same. They're both radical 6. But if they're different, which we'll get into more examples later, for example, like 3 radical 8 plus 3 radical 2, even if the coefficients are the same, the radical itself is different, so you can't just add these. You can only add and subtract when the inside radical is the same. So later we'll be learning how to make these the same and then so that we can actually add them. But if the unit rule doesn't apply and you can't just ignore it and add the 3's together, you have to make the radicals equal and you can only work with numbers that have the same radicals. Now that we have some rules explained, we're going to get into the practice problems. So let's do 5 radical 7 plus 3 radical 7. So as you can see here, the radicals here are the same. They're both radical 7, so you can just add the numbers in front of it, or you can also call them coefficients. So we're going to be doing 5 plus 3, which is, we all know, is 8. And then we put the unit or the radical afterwards. So it's going to be 8 radical 7, and that's our final answer. You never radicals. Like, for example, some people might think that you should do radical 7 plus radical 7 to get radical 14. but this is completely wrong, and you should never add the numbers inside the add or subtract the numbers inside the radicals, because that's not how you solve a radical problem. So make sure the main big takeaway here is that the radicals have to be consistent, and you only add the coefficients or subtract. Okay, our next problem is going to be 15 radical 21 minus 6 radical 21. So from last lesson, we learned that we should always simplify, and so I'm going to first, we already see that the radicals on both numbers that we are subtracting from have radical 21, so it's okay to subtract them. But we also need to make sure it's at its simplest form. But radical 21 is at its simplest form, so we can just move on and subtract the coefficients. However, if you had a radical with a number with a radicand inside of it that is divisible by a perfect square, it's always best to simplify it. So moving on, we're going to take the numbers from this problem and solve that first. So 15 minus 6 equals 9, and then we put the radical after it. So it's going to be 9 radical 21, and that's our final answer. Okay, next we're going to do a negative. So negative 10 times radical 11 minus 2 radical 11. It's consistent on both numbers, and it's also at its simplest form, so we can move on with the operations. So we're going to do negative 10 minus 2, which is negative 12, and then like you would do with a unit of measurement, you just put in the radical at the end. So it'd be negative 12 times radical 11 for your final answer. Now how about 9 radical 15 plus 1 radical 15? So 15 isn't a prime number, but it's also not divisible by any perfect squares, because 15 doesn't go into, 4 doesn't go into 15, or like 9 doesn't go into 15, so it's at its simplest form. So since it's consistent on both sides, we just focus on the coefficients. And so we do 9 plus 1, which is 10. And then we add in the radical at the end, so it's going to be 10 times radical 15, and that's your final answer. Next, I'm going to do negative 8 times radical 17 minus 4 radical 17. So 17 is also at its simplest form, and it's consistent on both terms. So we just focus on the coefficients, and we do negative 8 minus 4, which is equal to negative 12. And then, as we have done before, we just add in the radical at the end. So it's going to be negative 12 times radical 17. Next, we have negative 4 times radical 6 minus radical 6. And I mentioned this in a previous video, that if there is no number written in front of a term like a radical, then you automatically assume that it's just a 1. And anything times 1 is just 1, which is why we don't actually write it. But this is the same thing as negative 4 minus 1, which is negative 5. And then we're going to add in the radical at the end, which is radical 6. So our final answer here is negative 5 times radical 6. Next, I'm going to be doing 3 times radical 5 plus 5 times radical 5. And we also need to double check that radical 5 is consistent on both sides, and it's not divisible by any square roots. And indeed, it's at its simplest form, so we just focus on the coefficients to do 3 plus 5. I covered that up, which is 8, and then you put on the radical at the end. So it's 8 times radical 5, which is the final answer. Okay, now moving on, I mentioned this slightly before in the beginning. We're going to be solving expressions that have radicals that aren't consistent. So the example I used before was 3 times radical 8 plus 3 times radical 2. Now, I mentioned that you should never mess around with anything inside the radical, and you can't perform an operation unless the radicand, which is the number inside the radical, is consistent. And so because these terms are not consistent, as you can see, one is radical 8 and the other is radical 2, you cannot add them together. But we can change this to make it easier to simplify. So what I mean by that is a is divisible by a perfect square. And I'm just going to list them on the side so we can refresh our memory. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, and so on. And 8 is divisible by 4 because 4 times 2 is 8. And we're going to apply our knowledge that we learned last lesson of simplifying radicals that are divisible by perfect squares to this problem. We're just going to focus on 3 times radical 8 for now and try to simplify it. So 3 times radical 8 is equal to 4 times 2, and we can separate radicals. And then the square root of 4 is just 2, so you do 3 times 2 times radical 2, and you get 6 times radical 2. So basically we learned that 3 radical 8 is equal to 6 radical 2. And now if you look at it, if you look at the problem again, you can see that now it is indeed consistent because we have 6 radical 2 and 3 radical 2, and which makes it possible for us to add them together. So I'm going to put in a new page. So it's going to be 6 radical 2 plus 3 radical 2. And that's our new. And we just do this like any other problem that we did before. We just ignore the radical because they are consistent, and we just add the coefficients together, which is 6 plus 3 to get 9. And so our final answer is going to be if we go back, another way to approach this problem is that when you look at these two radicals, we can obviously tell that one is not simplified since 8 is divisible by 4. And to determine which radical you want to simplify it to, you just divide the simplified radical by the unsimplified radical. What I mean by this is that we know that 2, sorry for using so many colors, but we know that 2 is its most simplified version. So we're going to divide 8 by 2. And then if you divide 8 by 2, you get 4, which is a perfect square. So we know that 8 can be simplified down into radical 2. So radical 2 is what we're trying to standardize the problem to. And even though it can be confusing right now, as we do more practice problems, it'll get. Okay, so our next practice problem is going to be 2 radical, let me change the color, sorry. 2 radical 6 minus 2 radical 24. So what I just explained is that we look at the simplified radical and divide it by the unsimplified radical. And to our convenience, radical 6 is already at its simplest form, so we're going to divide radical 24 by 6 to see if it can be standardized to the same radical. And indeed, 24 divided by 6 is 4, so we know that we can change 2 radical 24 into something radical 6. So we're going to simplify this by seeing what radical 24 can be simplified down to. And radical 24 is divisible by the perfect square 4, because we know that 24 divided by 6 is 4, so we're going to turn this into 4 times 6. And that's going to get its own radical. and then we can simplify that into 2 times 2 times radical 6. So our final simplified version is 4 times radical 6. And now since both of the numbers in the expression can be used with radical 6, we can officially solve this problem. So now it's going to be 2 radical 6 minus 4 radical 6. And that's our simplified version of the expression from before. And since it is consistent on both sides, we can just ignore the radical and carry out the operation of the coefficients. So 2 minus 4, 2. So our final answer is going to be negative 2 radical 6. Moving on to our next problem, we have negative 2 radical 3 plus 3 radical 27. So by first glance, you can tell that this first term is simplified down because radical 3 there. So we're going to divide 27 by 3 to see if they can have the same radicals so that it's consistent throughout the terms. So 27 divided by 3, you should know that's equal to 9. So now, since the radicals are consistent throughout the terms, we do negative 2 plus 9, which are just the coefficients, and that's equal to 7. So we get 7 radical 3 as our final answer. Okay. Now our next problem is going to be 2 radical 6 plus 3 radical 54. That even though 6 is not a prime number and it can actually be divided into 2 times 3, factorized into 2 times 3, 2 and 3 are neither, therefore this term is at its simplest form. Now what we're going to try to do is do 54 divided by 6 to see if 54 can be turned into some form of radical 6 in order to carry out the operation. And 54 is indeed divisible by 6 because 9 times 6 is equal to 54. So we're going to simplify this down into 9 times 6. And then if we put it into their own separate radicals, we can simplify radical 9 into 3. So we get 3 times 3 times radical 6, or 9 radical 6. So now we're left with 2 radical 6 plus 9 radical 6. And now we can just default the radical 6 and just focus on the coefficients. So we do 2 plus 9, which is equal to 11, and then we attach the radical 6 at the end to get 11 radical 6 as our final answer. Our next problem is negative 14 times radical 12 plus 5 radical 3. And just by first glance, we know that 5 radical 3 is at its simplest form, so we're going to try dividing 12 by 3 to see if it can be standardized to one radical. And indeed, 12 divided by 3 is equal to 4, so we know that radical 12 can be turned into some form of radical 3. So we're going to simplify down this term into radical 4 times 3, separate them into their own radical to get radical 4 into 2 times radical 3. So now we do negative 14 times 2, which is negative 28 radical 3. So now that we have both terms at its simplest form, we can now add them together. So we're going to do negative 28 radical 3 plus 5 radical 3. So we made the radicals the same, so we focus on the coefficients. Negative 28 plus 5 is equal to negative 23. So our final answer that we get is negative 23 radical 3. Now the next problem I have is 2 radical 3 minus 4 radical 27. So since we just did a problem with a radical 3, we know it's at its simplest form. So therefore we divide 27 by 3 to see if we can realize the whole problem with radical 3. And 27 is divisible, so we can turn this into 4 radical 9 times 3. And then separate 9 and 3 into their own radicals so that we can simplify radical 9 into 3. And then 4 times 3 is equal to 12, and we attach the radical 3 to get 12 radical 3. And since now both terms are on radical 3, we can now subtract them. So 2 radical 3 minus 12 radical 3. So we on the coefficients to get 2 minus 12, which is negative 10. Negative 10. So our final answer is going to be negative 10 radical 3. Our next problem is going to be negative 3 radical 12 plus 3 radical 3. So this is kind of similar to the problems we've been doing. We already know that we can simplify this one down into radical 3, so we can do negative 3 times radical 4 times 3, and then do the simplifying process to get negative 3 times 2 times radical 3, or negative 6 radical 3. And now both terms are at its simplest form, so that we can add negative 6 radical 3 plus 3 radical 3. We just focus on the coefficients, and we get negative 6 plus 3 equals negative 3, or negative 3 times radical 3. So I hope it's a lot easier to understand now that we've done a lot of practice problems, and we'll just do one last one to finish off today's lesson. So the last problem I have for you guys is negative 2 times radical 45 minus 3 times radical 20. The numbers are slightly bigger than what we've been working with, and the one major thing different about this problem is that both of the radicals included in this problem are not simplified. So we're going to have to simplify both of them into one single radical that is consistent on both sides. Now, how do we figure out which radical we're going to simplify them down to? Well, first, I would just recommend simplifying each individual radical by dividing them with perfect squares that they can be divided into. And so we're going to look at negative 2 radical 45 first. So if you think about the perfect square starting with 4, smallest to largest, you can't divide 45 by 4, but you can divide 45 by 9. So we know that we can simplify this down into 9 times 5, because we know that 9 times 5 is equal to 45. Put them in their own radicals, and then simplify the square root of 9 into 3. And so our final simplified version of negative 2 radical 45 is negative 6 radical 5. Now we're going to do the second radical of this problem. So 20 is divisible by the smallest square root after perfect square after 1, which is 4. So we get 3 times 4 times 5. And if you just stop here and look at the problem, you can see that both radicals have a factor of 5. The other number is just a perfect square, so we're going to get rid of it, which means that the consistent radical that we're going to be working with is radical 5. So another way of putting this into words is that if you want to subtract two different radicals that are unsimplified, they need to have a common factor. So going along with this simplifying process, we can simplify down radical 4, or the square root of 4, into 2. Radical 5 as our final, well, not answer, but final simplified form. So the final operation, the operation in the beginning was subtraction, so we're going to do negative 6 radical 5 minus radical 6, 5. So negative 6 radical 5 minus 6 radical 5. And this should be pretty easy to do just at first glance. We look at the coefficients. Negative 6 minus 6 is equal to negative 12. So the final answer we get is negative 12 radical 5.